Hello. So my name is Nate Bade. I'm currently the program director of applied mathematics. Hello. My name is Nate Bade. I'm a teaching professor at Northeastern University and currently the program director of applied math Hello. My name is Nate Bade. I'm a teaching professor at Northeastern University and I'm also currently the program director of the Masters in Applied Mathematics there. And I'm here to talk to you a little bit about feature construction and why we should construct features by hand sometimes. So my background is much more in the data science machine learning world, but I want to at least go through one quick example of why we should often use prior knowledge when we have it. So the setup would be, at this point, we would have done some preliminary data analysis, data cleaning, linear methods, and multilinear regression. So looking at things like, taking medical data and predicting things like demographic information and class from just the diagnostic information, and showing that unfortunately you can do that quite successfully with just linear models. So in this case, though, we're going to look at a different kind of data and show that even a very, very small amount of data can be very feature rich. So here we're going to look at the Airbnb review data set for New York. And specifically what we're going to be interested in here is the relationship between some of the numerical data and the price. So we're actually going to drop all of the nice textual data in this case. So just as we've done before, we just include numeric. And we're also going to drop the host ID because it's pretty random and just do a little bit of cleaning. So if there's no reviews for something, then the reviews per month shows up as an. So just fill that in. And great, we've got nice clean numerical data. Let's look at the correlation. So we're trying to figure out which of these variables is best correlated with price. And what we see is that it's really not good. Basically nothing is. So with some of these things, so minimum nights, well, maybe that's just actually not correlated with the price. That could just be pretty random. But I'm very surprised that latitude and longitude don't have anything to say about price, right? And and we all should be, right? Latitude and longitude is going to give you all the spatial information, right? Where is this? Is it near a beach? Is it in Manhattan? Is it in the Bronx? Is it near Central Park? Like all of this kind of information should somehow be locked away in the latitude and the longitude data. But it doesn't appear that we can get it out using these sort of linear correlation methods. And the reason why it becomes obvious when you even just look at the scatter plot. Right, looking at the scatter plot, we see, a correlation. We're really talking about a linear thing, right? You go up a little bit in latitude and there's a corresponding increase in price. Or anti-correlation, you go up a little bit in latitude, there's a corresponding decrease in price. Here, the price seems to increase a little bit and then decrease. So it's not going to be a straight, tight, linear correlation. We also see here that we have some outliers that we need to clean up. So basically cutting all the prices that are less than 1,000. So just to recall, that is, we just grab the price column from the pandas data frame and look at price less than 1,000, and that'll return a true false vector. And and then this will only keep the values for which that's true. Okay, so we see a little bit more structure here, but it's definitely not going to be a linear thing. So, and I would encourage you, just this little exercise we can check and see that actually, a linear classifier composed of just those two things does not give us any very good results. Okay, so let's plot the latitude versus the longitude. And here's what we get. So we get a city with all of the sort of rich information, sociological information, historical information, geospatial information that comes along with that. Right, so hidden in those two columns is a huge amount of structure when we are allowed to understand them together. And we can actually plot the price on top of this. So using scatterplot has a color set over here. So C equals price. And we can throw this on top. And what we get is, well, it's a little distorted because the very, very high priced things are sort of zeroing out the low priced ones. But we can see that there is some spatial locality to price. If we want to account for that a little bit, then we will just use log here. And we can get a little bit of a better idea. Yes, so log will kind of will account for some of the large differences in scale. Then we can see, yeah, so okay, so we have higher price property clustered around Manhattan, parts of Brooklyn, and we have other places where we have lower price property. And so at this point, we can try to bring in things that we actually know about human movement and about how cities operate, and try to construct new features that reflect this, right? Like we can look at this and see the information, we can see the patterns, but getting a computer to be able to do it is non-trivial. So we can zoom in on Manhattan Island here just as an example. So one thing, as a first example of the kind of feature we could construct, let's say that I have the hypothesis that the closer you are to a subway station, the higher the price is, right? Better access to public transit and better price. So what do we need to actually do to verify that? So first, we need to get some data on where the subway stations are. That's not hard. NYC Open Data Project has it. But then second, we actually need to figure out how to build this, this new feature. And so the proposal that I have is, okay, so we want to know if a piece of property is near a subway station. So let's say the piece of property is located at xj. So this is longitude j, latitude j, for where j is indexing the listings. Then we can construct this new feature by basically, for each of the stations, so indexed by I, the metro distance is going to be the minimum distance from xj to one of the stations. Where here the distance is just the Euclidean distance, just the triangle Pythagorean distance. Okay, so we'll dig into actually how to do this and construct this. We would do this later, but we can just look at the results really quickly. And what do we get? Well, correlation isn't as good as I would like. Definitely does go down a little bit, but it's not very strong. And just plotting our subway map over Manhattan, we can sort of maybe see why. There's just a lot of subway stations. They sort of canvas the entire, they're well serviced and they sort of canvas the entire island. So it's maybe the case that the subway stations are not the right feature. But what is? And so at this point, I would, basically, if this was normal class, I would say to put people in breakout rooms and basically just to come back or to debate and come back with answers to questions of, so what are, or to come up with, what are 3 possible features that you construct out of the latitude and longitude data that give you a better indication of the price. And when I say identify them, I also mean, identify any data sources that you would need and give some sort of idea of an algorithm or an equation that would actually construct the thing for you. It doesn't have to be as thought out as this, but it should be a reasonable description of how you'd actually construct the thing. All right, so thank you very much for watching. If you want to, this notebook is linked below, and this is how I always do things, so the class can follow along with me if they would like, and have a fabulous afternoon.